Now we're going to look at linear inequalities in one variable. Properties of inequalities. You've got A, B, and C represent real numbers. Now I know you've done this before, but we need to look back over this. If you've got X is less than A, then if you flip the whole thing like with a pancake flipper thing, you've got A is greater than X. If A is less than B, if you add the same thing to both sides, or if you subtract the same thing from both sides, the inequality symbol does not change. If C is positive, and if A is less than B, you can multiply or you could divide, and the inequality symbol does not change. I wouldn't be saying this unless something's going to happen. But if C is negative, check this out, and A is less than B, if you multiply both sides by a negative, the inequality symbol reverses. Or if you divide both sides by a negative, the inequality reverses from what it was originally. So this situation right here, when you multiply or divide by a negative, the inequality symbol will reverse. Now these statements are also true, expressed with symbols less than or equal to, greater than, and greater than or equal to. So now that we're asked to solve the inequality, graph the solution set. Write the solution in I can't stand set builder notation. I want inequality notation. So if the directions say that, you need to talk with your instructor, but I like inequality notation. I can't stand set builder. And interval notation. And that's what we learned prior to this. So we solve these the exact same way as we do equations, except we got to remember this one instance here and what we have to do with the inequality symbol. So let me get rid of the parentheses by distributing through. Get X to the same side so I can add and subtract. Symbol does not change, so if I subtract 5X from both sides, subtract 12. So far, so good. Now, I'm going to divide both sides by -2. Right when you think that, flip. X has got to be less than 10. So this is my inequality notation. If I graphed it, if I have a less than, remember that is an open symbol, and I want my X values to be less than that. So they're going to -infinity. So I write that down because now I can do my interval notation. Infinity always, my interval, yeah, I said that. Infinity is always where this one's going, especially if your arrow goes out to the left-hand side, goes up to 10. Remember, a parenthesis is used when you have a less than or a greater than. So let's try this one. I got another parenthesis, so I've got 16 less than 8x minus 16 minus 3x plus 5. So I've got 16 less than or equal to, I'm going to have 5x minus 11. So you can move the 11 over by adding, and if you do that, you end up with 27. Divide by +5, so 27 over 5 less than or equal to x. Now this is why we have number 1 up here, because you really need to have x on your left hand side. So I'm going to put my pancake thing there, flip it over, so I can reverse that. These are the same thing. X is greater than or equal to 27 over 5. So there's my inequality. Graphically, you could change that to a decimal. Now when you have greater than or equal to or less than or equal to, it's a solid dot. And if you have X on the left, then depending on how the arrow's pointing, that's how you shade. So I'm shading to +infinity. So my interval notation, need a bracket, goes with a solid dot. So there's my solution set, there's my graphical solution, and there's my interval notation. Let's look at the next one. Distribute through the point 3. I'd have point 3x minus 1.2 less than 0.5x minus 3. So let me get x's to the same side. So I'm going to take my x's to the left, subtract that. I'm going to have a minus 0.2x. Let me add 1.2 to both sides. And that will give me a negative 1.8. And I'm going to divide by a negative. Reverse the symbol. And if I divide both sides by negative 0.2, I'm going to have x is greater than 9. So choose 10, put it in there, and see if it gives you a true statement. But there's my inequality. There's my graph. And my interval notation. I see fractions, and just like before, clear the fractions out. My common denominator will be 8, so I'm going to multiply by 8 on this side and 8 on this side. So on the left, I'm going to have an 8x. On this side, 4 will go into 8 2 times. Plus 2 into 8 will go 4. So let me clean that up. So I'm going to move my x's to the left. So if I subtract 8x from both sides, I'm going to have 0 is greater than 2. Well, you should know that that's not true. Even earlier, when we had equations, a false statement, 0 can't be 2, and 0 is not greater than 2. So this means there's no real solution. Okay, I'm going to graph these because I want you to see a picture here. I'm going to put x in, and then I'm going to put that one in. There's times when you really don't need the parentheses, but not to worry about when you do, when you don't. It's just safe to put parentheses around numerator and another parentheses around denominator. So let me do zoom 6, get this standard. Now this was this side, and the red one is this side. Looks almost like they're on top of one another. Let me go in just a little bit closer. Let me do zoom 4. Decimal window will get me closer. That is x. That is parallel to that line, and if you'll notice, it's above it. There's no way that this side can ever be greater than that side. For it to be greater, it has to be above. So that's why there's no solution on that one. Alright, let me look at the next one. Let me distribute through the 3 here. I meant to distribute. Okay, that would be 3x plus 8. This is 3x plus 8. Subtract 3x. Subtract 8. Is 0 less than 0? Less than or equal, excuse me. That makes a difference here. 0 is less than or equal to 0. So that right there means, since that is a true statement, all real numbers would be my solution. Now if I have to graph this, I just have to shade the whole line. Use a lot of ink that way. Now, if I have to do interval notation, it'd be negative infinity to positive infinity. Now, no real solution. If you had your graph, you wouldn't graph anything, nor do you have anything for interval notation, since there is no real solution there. Those were sort of odd. Oh, another one. Now notice I've got two inequalities here. The x in these particular types of problems will always start and stay in the middle. But because I've got fractions, I've got to get them out. So I'm going to multiply this by 6. I'm going to multiply the middle by 6 and the last one by 6. So 6 times 1 over 3. 3 will go into 6. That'll be 2 times. 2 into 6 will go 3 times that numerator. 3 into 6 will go 2, and 2 times 2 is 4. So 2 less than 3x plus 3. Subtract 3. Now because I've got a middle and a left side and a right side, I've got to subtract 3 from all three sides. All three parts? Yeah. Subtract 3, I'm going to have a negative 1. Subtract 3, I get 3x. Subtract 3, I get 1. Now I'm going to divide by positive 3. So I've got a negative 1/3 less than x less than or equal to 1/3. So I can graph this. There's negative 1/3. Here is 1/3. This one has an open. This one is closed. And I'm going to shade in between. Now you can shade here real solid, but you're wasting a lot of ink. So interval notation, coming in from the left, I have a parentheses. Going up, hitting my solid dot, I have a bracket. So that's my interval notation for that particular problem. Now you need to try some.